HVAC 360, episode number 52, Maintenance Access. Hey, welcome back, everybody, to another episode of HVAC 360. I'm your host, Matt Nelson. This week, we're talking about maintenance access, but before we get into it, I'd like to say, hey, yay, we made it a year, 52 weeks. So 52 weeks, even though it's been a little bit more than that, if you know the behind the scenes as far as when we started in building chatter and things like that. But 52 episodes, we have a complete set for a year. And we will be going on into our second year. So obviously we got some great things that are coming up, lined up some interviews, and hopefully we can get it out on a consistent basis. I always like to do that. I know the last couple of months have been a little bit rough. If you've paid attention, or if you're new, hey, don't worry. Nothing's wrong here. This week we're going to be talking about maintenance access. So what's so exciting about maintenance access? Well, to the owner, it's really the bottom line, being able to maintain their equipment and keeping it on the line and getting the best possible performance, the best, least energy they can. It's really important to them. So therefore, it should be very important to you as well. Both the design engineer and the commissioning agent really want to take a close look at maintenance access. It's not something to be an afterthought, and I kind of have a little 4-step process that I kind of like to take you through on going through this a little bit. Step 1, I name that step, does it fit? This is your design step. Step number 2, can it be installed and set up? That's your construction step. Step number 3 is, can it be maintained? And you would think, well, doesn't it end there? No, there's a step 4. Step 4, can it be replaced? Back in step 1, nobody ever thinks about step 4. Can it be replaced? I mean, what does it take to actually replace some of these pieces of equipment? If it's little, if it's like a cabinet unit heater that sits by the door, guess what? Not a problem. Do a little drywall patching, possibly a little bit extra finish or a different option as far as what you order, and that would be it. But say, for instance, you were replacing a chiller that didn't have proper access. Say you were replacing a air handling unit that didn't have proper access. That would be a problem. You would be long gone and possibly 20, 30 years down the road, possibly retired, so you may not care, but realistically, you should be on the ball with this. Do not leave it in the owner's lap. This is part of your professionalism, whether you're designing it or whether you're reviewing it for a commissioning authority. So, let's get into it. Step 1, does it fit? During design, very important that you have the equipment selection for your project picked out. This is really going to be the basis of design, but when you're selecting it, you got to make sure that it actually fits in the space that you provided. Now, obviously, mechanical equipment rooms, electrical equipment rooms, those always have an overabundance of space. Architects always give you more room than you can possibly ever need to fit all your mechanical equipment. Of course, I'm being sarcastic. They never give you enough space. But it's important to differentiate, being able to actually fit the equipment into a space and being able to maintain it. There's a real difference. I mean, I can pack a car better than anybody. I can fit anything into any sort of vehicle. It's an innate skill that I have. But just because I can do it with a car and packing equipment for going on a trip or going off to college, that's completely different than being able to actually get to the different pieces and parts that you've actually put into the space. Never pack a mechanical room. It's never gonna end up right. It's never gonna end up good. And it's not doing the owner any favors. So you're gonna have to be thoughtful about it when you plan it out. How's the maintenance guy gonna move around? What sort of equipment is in the way? I mean, a lot of times it may look good on paper, and this is the problem. You got to think a few steps ahead. So all the equipment may fit in a room, but what happens on the next step when you start overlaying the ductwork, overlaying the piping, overlaying the boiler flues, overlaying the, this, that, and the other thing? All of a sudden, you have a really tight space. You need to be able to think of that right during design. So you have the equipment selection and the design. So you have a piece of equipment that you've picked out your basis of design. You do that because, it's just simpler that way. You have your piece of equipment that you can schedule, that you know all the ins and outs, all the details. You have the cut sheet. You know how wide it is, how long it is, how thick it is. All the very specific details that you need to be able to draw it on a piece of paper. Well, and we'll get into equals later. But, I guess it's very critical on where you put it. And let me tell you a few things about making it too tight. If you make it too tight, did you factor in everything? There's a safety factor you want to flub in there, but you really, it can get eaten up rather quickly. When you get an allowance on a budget, there's certain things that that allowance goes for that are unforeseen conditions. Do you really have everything detailed out? Do you have the flanges on the ductwork? Whether or not they're half-inch flanges or whether they're 2-inch flanges. Do you have the base rail to the piece of equipment? Does it sit on a equipment pad, equipment curb, some sort of concrete curb that you have in the mechanical room? Is the room going to be flat? Is there structure overhead that you're not necessarily accounting for? You really have to play this out, and I guess I'm focusing on mechanical rooms a little bit now. But you really have to you really have to lay it out and think it through about what exactly you're going to do, because if you're going to take a 90 right off a piece of equipment, it's not going to be as close as you think it's going to be. You can lie to yourself and say, it's just going to go out, just come out, the 90-degree elbow is just going to come off the piece of equipment like this, and that's how it's going to be. But you know what? You're not an installer. You're not a contractor. What you don't know is that you need, an extra 2 or 3 inches because you have to have some sort of, coupling or flange or something like that in there to be able to connect the piece of equipment to the ductwork. And it's that oversight that if you make it too tight, guess what? You're going to get bitten at the end. Your system's going to be restricted on the airflow, and you're going to end up paying the penalty and energy by increasing the static. Some of those system effects. So you want to make sure that you allow yourself enough space, enough breathing space. And we're going to kind of go over some of the construction implications a little bit later. But let's get back to that or equal. So you have your basis of design, and in most cases, you're going to have an or equal, which means that you're going to have 2 or 3 similar products that you're going to find acceptable. That if the contractor wants to use B or C instead of your A product, they can go ahead and do that. It's going to be fine. But when you're talking about big piece of equipment, it's not necessarily, very important with little piece of equipment. Sometimes it can be. But with bigger pieces of equipment, that can change by, 6 inches, 12 inches, 3 feet. It really depends on the situation, but it can grow that much just from your base of design to what actually gets installed. When you look at air handling units, typically you're going to take the look of the cross section. That's not going to change too much. You might go a couple inches narrower and a couple inches taller, depending on what that cross section is. But you're going to have that flow that needs to be constant. What happens with air handlers typically is that you're going to end up with another section, or the section's going to be different, or it's going to be longer, because the air handlers are going to be, built up on these sections or modules that they're going to put together, and those are going to be a different length. So length is really critical when you're evaluating the different or equals. I mean, frankly, most people just put down 2 other manufacturers, and they don't even bother with or equals. but it's really critical if you have a space that's really, really tight, you want to take a look at those or equals and see if you can't get the dimensions of what would be submitted by the contractor to make sure that you have enough space. So one thing you want to be able to do, especially during design, is with specifications. Now, what do I mean by that? Specifications in relation to the maintenance staff. Because it's one thing to say, okay, I'm going to put this piece of equipment in, it's going to get installed, everybody's going to touch it once, we're going to turn it on, and it's going to run. Well, I speak from personal experience where you take the same panel on and off of a unit, you do an adjustment, you put the panel back on, you test it out, it doesn't work. You take the panel back off, you do another adjustment, put the panel back on, test it, doesn't work. Take the panel back off. But you understand. You get the message here. But realistically, if there's a way, if you ask just that one additional question, is there an upgrade? Is there an option that I can purchase with this piece of equipment that will make maintenance easier, where they have just a handle to turn instead of having to have like 9 different hex head screw bolts that they have to undo each time they want to take this panel off? I mean, not only is it going to be better for the maintenance guy, but it's just going to be friendlier all around. If there's that additional thing, and if you're a manufacturer out there, hey, look how you can make your equipment more maintenance friendly. So, engineers out there, take a look at the specifications, see what you can do about that. You want to make sure that you're factoring that in. And if you can, at all costs, because typically these things they're not budget busters. They're a few $100s. For a piece of equipment that's thousands and thousands of dollars. So it's really not that big of a deal in most cases to be able to specify better handles, easier access, different types of fasteners, that just make it easier on everybody all around. In design, it's critical to coordinate with other trades. Do the best you can. I mean, you want to make sure that your electrical panels aren't behind your air handling unit and you're blocking that code clearance distance. Obviously, those are some of the dumb things that you can really coordinate ahead of time. You're going to have, and I call this kind of like preliminary coordination, because you're going to get into as-built when you get into construction. That's going to be a whole different form. But for right now, you want to make sure that all the pieces, parts have their own little home, have their own little space around them. Everybody's kind of like a happy little family living in those mechanical and electrical rooms. You don't want to make sure that there's pipes where there shouldn't be and ductwork that's not going over what it shouldn't go over. So do some preliminary coordination with that. Obviously, absolutely a key. It's what every commissioning agent should be looking for during the design process. A couple of different tips for the design process. You want to watch the mounting height. And what I mean by that is sometimes you have a ceiling that's, say it's at 9 feet, but you have, for whatever architectural reason, you have a plenum space that may be 4 feet above that. Well, guess what? You don't want that terminal unit, that VAV box, way up there, so you have to actually deconstruct the ceiling grid to be able to get a ladder up there to be able to maintain it that high. You want to make sure that all your access is decent for all your equipment. You want to make sure that you identify drywall ceilings. And that hit home just recently with something you didn't think about, and all of a sudden there's a drywall ceiling there. I mean, that might have been just a brick wall. I mean, there's some things you can do to a drywall ceiling to get access, but none of it's pretty. A drywall ceiling's meant to be, this nice finish. From an architectural standpoint, you just want to see that. You don't want anything else. So consider it a little game with yourself. If you have to put a hole in a drywall ceiling for an access door, you've lost. Just stay away. Try to organize your equipment and your access and your different accessories so you don't have to penetrate that drywall ceiling. And know it ahead of time. I mean, you might just have a loose conversation saying, okay, where's the drywall ceilings going in this place? Have a conversation with your architect. Talk to them about it. And while you're at it, while you're talking with them, you might want to talk about access around the roof. I mean, I've said it time and time again, but access around the roof, getting to different locations, absolutely critical when you're a maintenance person. Even when during construction, they might have ladders tied off in certain places. But once those ladders go away, I mean, all you commissioning agents understand, when all the construction ladders go away, guess what? Now you got to start lugging things around to be able to get access to different equipment. It's a lose-lose situation. Architects, please kind of, just take them through the different pieces that need maintenance. I mean, and frankly, that's pretty much everything. If you have a roof drain, you need maintenance access. It might be a different kind of maintenance access, but, it might not be lugging a box of filters up to an air handling unit, but you still have to actually get to that space. And if you have a multi-story building with a slick roof, that's not going to cut it when you're trying to put a ladder on it. That's going to be unsafe, and that's really no good. Okay, so that's design. Those are some of my tips. Now we get into step 2. Can it actually be installed? Now this is where you want to do walkthroughs when you're in. Nothing is better than walking through and identifying things, during construction. Whether you be an engineer, it's going to be essential for commissioning authorities. But you want to be able to get through, walk through construction, see how the maintenance is going. Because obviously, if something's not quite right, and you get it just at the time the equipment's set, you have a chance to be able to move it. If you don't hit it at that time, if you're doing it just before the ceiling gets buttoned up, it's way too late. Nobody's interested in moving it. They'll just kind of drag their feet until the ceiling goes up, and then they'll just raise their hands and go, I guess I can't do anything about it now. At that point, you get into an argument, and then it causes a bad situation if you really, really have to have it moved. So, really, when you're an engineer or commissioning authority, get there early, take a look at the maintenance access when you can. And really, it's kind of an evolutionary process because, construction is, it's first this, then that. So when you look at it one day, you may come back to it in 2 or 3 days, and all of a sudden, that maintenance access is completely blocked. I've had that happen in more than once. So coordination drawings. These are the things that really should, be the driving force, the telling, the proof in the pudding. And what these coordination drawings are, typically they're a set of drawings that are started by one of the contractors, and then they proceed to be sent to different contractors, and everybody draws their own stuff. In BIM, this is supposed to be smoothed over, but at least today now, from what I see, coordination drawings are absolutely key because things, the engineer's drawings are drawn diagrammatically. This is really, it's exactly this. Here's what I'm constructing. Here's what I'm putting in. And typically, the guy with the biggest stuff or the most important stuff goes first. Typically, it's going to start with a HVAC contractor because his ducts are the biggest, and they just can't, they can move, out of the way, up and down, things like that. But realistically, you don't want to if you don't have to. Next, the plumber gets in the mix, and then the electrician or fire protection, telecommunication, different trades. It depends on the sensitivity of it. And if there's a coordination issue, they'll work it out in the field with a foreman and things like that. But there's no, their goal is to get it to fit. Their goal is not to have it necessarily maintainable. And the real problem is that if you think about electricity and you think about the electricians and their equipment, if you don't have the proper clearance in front of a piece of switchgear, guess what? It's getting flagged. The occupancy permit is not going to be issued. If there's a junction box that you can't get to, guess what? It's getting flagged. It's getting moved. It's being corrected. These are all code issues. Code for safety. You know what's not code? Maintenance access. Maintenance access is not code, at least to my knowledge. So it's often ignored by the rest of the trades. They just have to be able to install it. You know, the big trick. I just have to get access enough to get it in once and to have it run and run right. But nobody has to think about maintenance. So that's kind of the whole reason why, I'm going through this, is to talk about maintenance, to talk about the importance of the access to this. Of course, this can always come back and bite contractors in the foot. Because at least with a mechanical contractor, they typically have 2 or 3 subs that are rather important. There's the controls contractor, there's the balancing contractor, and then there's the insulator. So why is it so important? With a piece of equipment, you got to be able to get to the controls panel of these different pieces of equipment. And I'm talking about, anything with intelligence, terminal units, HVAC equipment, things like that, not necessarily accessories like dampers. But you have to be able to get to it and program it. And you want that to be as easy as possible. Balancing. It has to be able to be balanced. Now, here's the key with drywall ceilings. I've run into a scenario recently where there was ductwork laid out, there were balancing dampers installed, and drywall ceiling followed up. Guess what? Nobody's getting to the balancing dampers. Nobody's going to put multiple holes in that ceiling with dampers, with access doors, to get to those dampers. All practical purposes, dampers need to be moved once, maybe, and then they're good. It was really one of those things that just didn't get a lot of thought. If this had been picked up in design, that would have been better. But realistically, now they're kind of behind the 8 ball trying to figure out exactly what to do. So think about the balancer when you're thinking about drywall ceilings, because it's not always about the big pieces of equipment, the terminal units, whether they be heat pumps or VRF units or fan-powered VAV boxes or VAV boxes up in the ceiling. Sometimes it's just as simple as a valve, a drain, access, a damper. It's just that easy. Think about some of these things. I mean, the problem with a lot of the accessories is sometimes they're not shown by engineers. Which is either good, bad, or indifferent, but they're still going to be there at the end product. And if they're not thought about, then they're going to get forgotten. So you need to make sure that you think about those things when you're going through your design. But obviously, it's critical for the contractor to know that if there's a drywall ceiling there, hey, he better flag it and get an RFI to the engineer as soon as possible. Because once those ceilings go up, he doesn't want to have to pay somebody to tear them back down and put them back up again. So, insofar as the insulator goes, insofar as that guy goes, or gal, they're putting up insulation around ductwork that's probably already installed or piping. If it becomes increasingly difficult, you want to make sure that insulation goes in and that they do a quality job. You want to be able to empower them to be able to do the best job they can. The same thing goes with the controls guy. Same thing goes with the test and balance guy. But you want to empower the insulator to be able to get all that insulation in a neat and workmanlike manner. What you don't want to do is pinch the ductwork up to the ceiling so they can't actually get the insulation around it. Or when they do it, It's going to be torn. It's going to be partial. It's going to be, it's just not going to be in a good scenario. Again, this is why you don't want to, pack that mechanical room with 100 pounds worth of equipment when it's only sized for 80. Moving on. Step 3, maintenance. Okay. Now we want to be able to think through, now that we've actually gotten it installed, and gotten around it. You want to be able to, get up to the equipment. You want to be able to, touch and feel everything. With maintenance, there's a certain number of things that you have to do with a piece of equipment, depending on what it is, how big it is, and things like that. But I would, make a little matrix for yourself, whether or not they have to change filters, whether or not there's belts with the equipment, whether or not they need to be, have bearings greased. If you don't know these things, when you select the piece of equipment, maybe it's a good idea just to talk with your manufacturer's rep a couple minutes longer and say, hey, by the way, if to maintain this on the long haul, what do I have to be able to do to get things done? Whether it's cleaning the coil or washing out the drain pan or whatever. Find the couple of things and just have that in your mind when you're laying out these pieces of equipment. And that will give you a little bit of better perception of what the maintenance guy is going to have to go through. I mean, you don't want obviously, here's my list of most desirable features for a maintenance guy. I want somebody who's a contortionist. I want somebody who's small and also tall. I want somebody who's as thin as a rail. These are kind of the perfect maintenance people in my mind, because you know what? In reality, the types of systems that they get, that's exactly what you have to be able to maintain some of this equipment. You have to be a contortionist. This should not be your goal. This is not a good, goal to set for yourself. You want to be able, just about anybody to be able to, go up and maintain the equipment. You don't want to be, you don't have to have any sort of special equipment. Or, if you do, make sure that it's not, just for this one piece of equipment. The worst thing that you can do, and I've seen it happen, where you have a cabinet unit heater in a foyer that's, about 30 feet high, that you actually have to get a scissor lift into the vestibule and then raise it to be able to do any sort of maintenance. Because you know what happened to that one? It never got connected. It got installed, and the electrician forgot about it, and the insulator forgot about it, and the plumber forgot about it. It was bad news all the way around. Why? Because it was 30 feet in the air. Not even contractors wanted to go up there once to be able to fix it. It was out of the way, out of sight, out of mind. Nobody thought about it. So it sat there and did nothing. That's not what you want to do in design. That's not what you want to have to do for maintaining the equipment. You want to have something, if it's going to be something special, have a conversation with the maintenance staff. If they have to purchase a scissors lift, especially for that, guess what? Make it part of the contract. Make it part of the project. So they get that turned over to them so they can do proper maintenance. But that should not be your goal. A lot of times you have different sort of light bulbs that are in these these grand foyers, these entry lobbies. How do they get changed? Think about that. When a light bulb burns out, how does it get replaced? Is that the case? Is that a scenario for, hey, you know what? Let's get LED lighting. Sometimes it's not a simple case. When you have the difference of, a different, like a high school cafeteria that has high ceilings, that might be, one scenario. But immediately adjacent to it, have a big auditorium with, seating that's sloped. Different scenario whatsoever. Could be the same type of lighting, but you're gonna have to have two different ways of changing each of those light bulbs. If at all. You might wait till they, nearly all fail before you replace them. But that's something that you need to think about beforehand. I mean, that's the whole reason that I'm kind of going through this, is just to kind of give you ideas of, what it's like to be a maintenance person, to go through there and to have to be able to maintain this equipment. I've had scenarios where maintenance equipment actually had to, there was 2 air handlers that were on a mezzanine, and the only way you can get to this mezzanine was that you had to climb up this ladder, this vertical ladder, and so if you had to get filters for these units, you actually had to kind of use a rope and drag them up through this little shaft that was about just the right size. I mean, person-sized shaft. So it was really, really a nightmare. And I can't imagine that, what's going to happen when they actually have to take out these 2 air handlers. But really, that's step 4. So let's move on. Step 4, the step that gets forgotten. What happens when you need to replace it? What needs, when you're going to take it down and put something else back up? Are you going to be able to do it? Are you going to have to move a ton of conduits? What happens with the air handling unit that's up in the mezzanine? Do you have to cut it apart? Is that something you need to do? What about, okay, I can get to the, I can, take out a louver. Are the louvers big enough? Do I have to actually deconstruct some of the wall? Did you put an oversized louver there so you can get some equipment? Great, now I got it on the roof of the place. Can I actually get a crane to it? Or is it someplace that I actually have to get a helicopter to actually do a remote lift? These are some of the things that you need to think about. I mean, there's big pieces of equipment, especially, and this is kind of the trouble that you get into in some of those mechanical rooms where you pack it so tightly that you can't get maintenance access. What happens when you need to replace something? Well, you got to remove 2 or 3 other pieces of equipment to get that third piece of equipment out. Sometimes you can cut it apart, but guess what? You got to get something similar back into that spot. So sometimes it works, sometimes it doesn't. But you really, think about some of those things when you're going through your design process, when you're going through your commissioning review process. Really, when you're doing this, I mean, when you think about it, these pieces of equipment are built to last 15, 20 years. Realistically, they might go longer. It might be 30. But when you're looking at a building that's 50 to 100 years old, or has that potential to be used that long, and sometimes even longer. I mean, I don't think anybody necessarily builds a building that's going to be they plan on demolishing in 50 years. But I mean, there's scenarios out there that it might be a developer, but realistically, that's how long people want to just use the building until it just falls apart, or it's too expensive to renovate or update. So I mean, that's it's like 2 or 3 times the length of a standard piece of equipment. So beyond the life, and you want to be able to make sure that equipment can get replaced when it needs to, and that there's a minimum amount of hassle in doing that. If you can do that, if you can have a maintenance guy get up to a piece of equipment, do the proper maintenance, and be done with it, and then at the end of the day, when the equipment fails, that they can have a contractor come in there and remove it without interrupting any of the other systems that are around it. That's when you know as a designer that you've succeeded. But until that time, you got to think long and hard, about the systems that you're designing, the layouts that you're using, the recommendations that you're making, and the things that you're looking at as far as commissioning goes. So, hope everybody got something out of that. I think those are the 4 steps. If you disagree with me or have additional comments, I'm always open to feedback. You can send me something at matt@buildingx.co, Or you can follow me on Twitter, Twitter @BuildingX. And if you want, you can either sign up for my newsletter and get some inside scoop. That's at buildingx.co. Or you can find me on LinkedIn, not too hard, and connect with me. Glad to connect with anybody who's a listener of the show. I appreciate each and every one of you. I know you're the top 3% of the HVAC industry. So congratulations to you. Good luck. Continued success. Let's go into the second year of HVAC 360. Remembering to know what you build and share what you know.